Right. The other day we saw OSA reference model, but we have not completed it. So we are going to complete that and then we'll move on to the new topics. OSI, Open System Interconnect, OSI. This is a standard which is prescribed by ISO. ISO, you might have heard about ISO, the certifying company. So they certify various things like ISO certified hotels, ISO certified um, soaps, medicines. Likewise, ISO certified model for network devices to communicate is OSI. OSI stands for Open System Interconnect. This is standardization organization. So there is a model referring which the devices are designed. So there is one model which everyone on earth refers whenever they design a device to be a part of network. The other day I told you we have various vendor sold and not provided laptops. I'm using Dell laptops. You may be using HP laptop or another series of Dell laptop, not the same series what I have. I'm having Latitude E5430, or some of you may be having Toshiba, Sony, various vendors who sells laptop. Whatever the vendor may be, the communication happens. When I send a mail, you are able to receive it. It is possible because the laptop makers, the operating system designers, they all referred one common model called OSI, one common book called OSI, Open System Interconnect. So whoever makes it tastes the same thing, whether it is in US or in India. KFC tastes same. Kentucky chicken is the same taste. Whoever makes it, that doesn't matter because they all refer one common book when they prepare chicken popcorn. Likewise, any device that is referred that used OSI as a reference model can interact, can understand, and communication is now possible. So what is this model explains? This model explains the 7 different steps in preparing the packets for communication. So it's both hardware and software involved in communication. Right? We need hardware, definitely we need hardware like laptop, and we put the software like Microsoft, Windows, and both work together for us in preparing a data. that we want to send. And this data is carried through a medium, through a media, maybe a Wi-Fi or wireless or fiber optics, and it is routed using routers, switched using switches. That's how you are able to hear my voice right now, and you are able to see my screen. Though there are many thousand miles away, that that's not a barrier. You can hear me well, I can hear you well, as if we sit very opposite. Yeah. So every device that is in between my laptop and your computer is designed by referring this one common model called OSI, Open System Interconnect. See, that's why the name open. The systems are open to interconnect and communicate. Now, the 7 layers, it starts from layer 7 actually. Application, layer 6, presentation, layer 5, session, 4, transport, network, data link, physical. So we got this layer 1 to layer 7. Always physical layer is layer 1, and always layer 5 is session layer. So you cannot change the sequence, you cannot shuffle it. It is in this order, needs to be remembered, because this is how the packet is prepared. So what comes first when a device send the data? It is the application layer comes first. On the receiving side, the packet is getting received in physical layer. Please understand. We have two things here, the software and the hardware. The sender uses a software, which is an application layer, to generate traffic. Right now, I'm using a software to generate traffic. What is that? That Google Google Chat. Yeah. So that's what Google Hangout. Google Hangout is what we are using to interact daily. We use Google Hangout to talk and share screen. So what it is? It's an application layer. It's an application. It's not a hardware, it's a software, it's an application using which I generate traffic. And now that traffic comes to you, your laptop. This is your laptop. This is my laptop. Your laptop receives it in a small component in your device called Wi-Fi adapter, a wireless adapter. Or if you are connected through wire, it is received through a physical layer called the network interface card, NIC card. So both the Wi-Fi adapter or NIC card, network interface card, both are physical layer. So on the receiving side, it is received in the physical layer and goes to the top to show the screen and my voice through an application. So you're also sitting with an application, listening to this class, watching this video that I'm sharing with you, the screen that I'm sharing with you. But it's me, the one who generates the traffic, so it starts from application layer, goes down to physical layer, prepared very nicely with all the 7 ingredients, and it is carried over the network devices, and you receive it in a physical layer, and then it is appearing for you as a data in the application layer. So sending side, it is the application layer, the first, but you should not call it as layer 1. It must be called as layer 7 always. Application layer is always layer 7. Even though it looks like layer 1, as per the standard, application layer is 7. So you cannot change that. If we can change that, then it cannot be a standard. Layer 7 is an application layer. So we use the application layer, applications, to generate traffic, not only to generate traffic, to read the traffic that we received, we need that same application layer. So on both the side, the application layer is important. On the sending side, application layer comes first. On the receiving side, application layer is the last station where the data is seen. So beginning and the end is application layer. Next, the presentation layer. You see, the applications need to be handing out the data to the network. The applications that we are using, like Google Hangout, they recognize my voice, they copy my voice through the microphone, they capture the screen that I'm sharing. Now these two things need to be given to the network in a network understandable language. That is why we call this presentation layer. So presentation layer presents it to the network. Whereas on the receiving side, from the network language, the presentation layer takes and converts to the language which I have sent, the human language. So when you receive my voice and this screen share, my data, you don't receive in a binary format or a machine language. You hear my voice through the speaker and you are able to see my screen, which means the data which is going in the wire in the form of zeros and ones in binary is being converted, presented to you back in the same format which I have generated, the voice and video. So the presentation layer is on either side. Here, from the application to the network, the data is presented. Here, from the network to the application, the data is presented. So presentation layer comes on either side. So the job of presentation layer is to encapsulate with a machine language with a network understandable language. All right, so now the presentation layer hands over the data to session layer. Session layer provides the time frame. Time. See, a computer may be communicating to various remote devices simultaneously. So every services that is running, that is utilizing the network, needs a time frame so that there won't be any um, conflict with services. See, if someone wants to visit the prime minister or the president of the nation, we need to take an appointment and we go exactly the time that is given to us. Only then there won't be conflict with other who wants to see the president. So there is a time frame given for us to visit, and when we go in that time, between that time, the range of time that they give you, there is no conflict. They allow us. Likewise, for every services that is using the network, there is need for a appointment time for the data to go out and for the response to come in. There is a time needed. That is what given by session layer. So sending said session layer says, okay, this is the time you need to get processed and go out. And now the receiving side, it receives saying, okay, I received the packet at this time, and I'm going to respond within this time because the sender cannot wait a long time. So I need to respond as soon as possible. So it has got time frame for every request and response, which is maintained by a layer called session layer. And then the the data comes to this layer called transport layer. Transport layer is responsible for transportation. You see, transporting a huge volume of data may be a challenging one if you don't have big processor to process that huge data at once, to carry that big data through wire at once. The transport layer makes it easier to carry and process. Transport layer breaks the large volume of data into small pieces so that it can be easily processed and carried over the network. So transport layer takes care of transportation, means it takes the responsibility of making the transportation easier by segmenting the data. By segmenting a large volume of data into small pieces, transport layer takes this responsibility, guarantees easy delivery of data. Segmenting packet happens here. So a large volume of traffic is generated by the application layer, and this big volume of traffic cannot be sent and processed at once. So when it comes to transport layer, what it does, it segments into small pieces, and it numbers. This is the piece number one, this is second piece, this is third piece. So sequencing is also done, arranging it on the receiving side. When the packet comes here, the transport layer arranges. See, the first piece that the receiver received may be piece number 2. The second piece may be 1. The third piece of data may be 3. It is not arranged properly. So it's this receiving side transport layer rearranges according to the transport layer sequence number. So this sequence number helps to rearrange, and it is arranged in the same format in which it is sent. So on the sending side, segmentation happens. On the receiving side, arranging the segmented data into one single big data, rearranging it as per the sequence number happens. So transportation made easier in the sending side by segmenting the data and sequencing it. But that segmented small pieces needs to be rearranged because sometimes the third piece go first, second piece may go second, first piece may go last to the destination, because internet is a big web. One piece may go via one path, another piece may go via another path. So sometimes the data which is sent later goes first. So on the transport layer collects everything and sequence it and then gives to the session presentation application. So the reverse process happens on the receiving side. Fine. Now after transport layer, network layer. In network layer, every segmented data means this small piece, every piece receives IP address. The source IP address will be my IP address. The destination IP address will be your IP address. That's the responsibility of network layer, providing the source and destination IP address. And the data link layer provides the source and destination MAC address. No, this will not be your MAC address. When I send my data first goes to my gateway. So my MAC address and my gateway MAC address. And then it keeps changing. The MAC address will keep changing till it reaches you. The MAC address will change. See, if it is only two devices connected back to back, then my MAC address will be the source and your MAC address will be the destination, for which my device and your device need to be in same network. For example, 10.0.0.1, 10.0.0.2. You see, both are 10 networks, same network, connected just back to back via wire. But that is not the case, right? You are in different network, I'm in different network, geographically in different region. So definitely you need a lot of networking devices like router. That router's address is what called as gateway. So I send my data to my router, and my router routes the packet to your router, and your router delivers it to your laptop. So not only my router and your router, there are many routers in between that carries our packet from one part of the world to the other part. So those devices in the middle, their addresses will be seen here in the data link layer. So MAC addresses will change for every hop. For every hop, every routing device from one router to another router you go, the MAC address will change. But the IP address will never change. And then the packets are now sent over the wire in a binary format. Now, who converts it into binary format? The physical layer. See, the presentation layer, what it did, it took the human understandable application layer generated traffic, presented to the operating system, which creates the packet, prepares the packet, and the preparation is done up to here. And now it is converted into a electrical signal. Or if you are sending through a fiber optics, then it will be sent to a light signal. It will be converted to a signal called light. That is how light can carry data. Yeah, that is how in fiber optics the data is carried. Data is carried in the form of light. Light travels faster, so fiber optics are more faster than the physical wires, which is carried using Ethernet technology. Fine. So the receiving side, the packet is received on the physical layer, and the receiving router devices check the MAC address. If the destination MAC address matches its own, then they accept the packet. And now the network layer checks the IP address. If your IP address in the destination field matches your laptop IP address, then you understand this is for me. And then it goes to the transport layer, sequence it, rearranges the data in sequence, and then changes the time frame after receiving, gives the data to the presentation layer. Presentation layer puts it into an application so that you can receive the data that I have sent. So this all happens in milli nanoseconds, very fast. Even though you and me are sitting many miles, many thousand miles away, this all happens just in nanoseconds. This is how the communication happens. This is the communication standard, OSI. Now, about transport layer, when we speak, there is a protocol called TCP. In transport layer, there is a protocol called TCP. TCP stands for Transmission Control Protocol. Transmission Control Protocol, TCP. And there's another protocol called UDP, User Datagram Protocol. Datagram is one word, User Datagram Protocol. These are the two protocols that works in transport layer. Transmission Control Protocol and User Datagram Protocol. We are going to see the difference between these two now. But before that, let's also finish talking about network layer and transport layer. In network layer, we saw there's a IP address. It is because there is a protocol called IP working in this layer. Now this IP address is 32-bit size or 128-bit size. IP address version 4 is 32-bit. IP address version 6 is 128. And about the MAC address is 48 bits always. MAC address is only one size, 48. IP address is of two size. If it is version 6, 128. Version 4, 32. Version 4 is what we have for many years now, more than 30 years. IPv4 we have used. Now IPv6 has become a standard in 2000, in the year of 2000. So now that has also reached 24 years now, 23 years. IPv4 is IPv4 is much older than more than 40 years. IPv4 is more than 40 years. IPv6 is almost now 23 years. But IPv6 have not much deployed on the end devices, end systems like our laptops. But in the core of the network, in the internet, everywhere it is IPv6 now. Everywhere IPv6 in the core. So the size of IPv4 is 32-bit, size of IPv6 is 128-bit, size of MAC address is 48-bit. We should not forget these things. Now let's go to this transport layer. Sorry, one more thing before I go to this. IP address we assign. MAC address is there on the laptop. What about these layers? Whatever that is necessary for these layers to function is carried out by operating system. So you don't need to worry about application, presentation, session, transfer. It is the job of operating system to do the functions of application, presentation, session, and transfer. Now, let's talk about the difference between TCP and UDP in transport layer. Why these two protocols and what is the function of these two protocols? See, as the word says, transportation, transport layer segments the large data into small segments. That's what we learned. But now when you try to give transport carry the segmented data, there is two style, there is two ways, there is two methods of transporting the data. Two methods. One is TCP way, the other one is UDP way. The TCP method of transportation is connection oriented. Connection oriented. This is connectionless. What does that mean? Connection oriented and connectionless. TCP is connection oriented. UDP is connectionless. What does that mean? TCP, before sending data, I'm sorry, you are saying something? So now, what is this exact meaning of connection oriented and connectionless? It is before sending the actual data, confirming that whether we are talking to the correct destination or not is what establishing. And say for example, When I call you over phone, I say hello. I don't say immediately as soon as someone picks, I'm not going to say what I want to say. I I say hello and I wait for your response. And when I hear your voice, I understand, okay, the right person on the other side. After which I send, I tell what I want to say. I say what I want to say. So before saying the message, before conveying the message, we simply say hello to acknowledge that we are connected to the right person, right? So knowingly and unknowingly, everyone does this. Whenever they call, the first word they say is hello. And on the other side, if there is no hello coming, then we keep sending hello, 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 till the other side say hello. We keep saying hello, and then there's a voice coming from the other side, hello, and now we are comfortable to share the data. Now we have an acknowledgement that the right person is on the other side to receive my message. So connection oriented is acknowledgement. Connection oriented is establishing connection by sending hello packets. In another word, it is also called a synchronization packet. Sync, syn packets, syn packets, synchronization packet. You send a hello and then wait for acknowledgement, wait for the response hello. No, that is what called as acknowledgement. Once the hello comes back from the other side, after which the data is sent. The response hello is what called as acknowledgement. We don't have this approach in UDP. We don't have this approach in UDP. So UDP is connectionless. UDP is like as soon as someone picks the call, you start conveying the message. Phone is ringing. As soon as someone picks, you don't know who has picked. You keep talking. You are not sure whether there is a receiver hearing your voice. You don't care about it. As soon as someone picks, you keep talking, and then you hang the phone. So there is no guarantee that the receiver received your message, but the message has been sent for sure. This is what we call as connectionless. Don't think connectionless means a wireless communication. No, 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 no. Connectionless here means before sending the actual data, we don't send any sync packet or acknowledgement. We don't wait. Just sending the data that you want to send is connectionless. Whereas connection oriented is before sending the data, you send a SYN packet. That's not actual data. That is just a synchronization packet to check whether the receiver is ready to receive. So you send a SYN packet and the acknowledgement comes from the receiver. After getting acknowledgement, you deliver the actual data. This is what we call as connection oriented. So this connection oriented is reliable. This is just best effort delivery. Best effort. Best effort delivery. So it is simply sending to the destination address. I cannot use the word unreliable. Even though it is unreliable, we are not sure, guarantee that the receiver has received it. I cannot say unreliable. Then if I say unreliable, then you may think like why you are using unreliable communication. See, both are important. Both TCP and UDP are important. Wherever fast communication is needed, UDP is used. Fast. Because you don't send any SYN packet and wait for acknowledgement. This is just sending as soon as the connection is route is there. Whereas in TCP, before sending data, you send SYN packet, wait for acknowledgement, and then you send some data. Again, you send SYN packet to make sure still the connection is there, and then wait for acknowledgement, and then you send the remaining data. So TCP is reliable but comparatively slower. It is not that slow, it is not that bad slow. It is fast, but compared to UDP, it is slower. See, in TCP, you have a guaranteed delivery. Guarantee delivery, where you don't have that here. No guarantee. Not sure whether it is delivered or not. But in TCP, you get an acknowledgement, so it is guaranteed. Both are important. Right now, the communication that I'm doing, the communication that I'm communicating with you, uses UDP. Why? In between my voice packet, if there is a SYN and acknowledgement packet, then there will be a voice break for you. So not good to use TCP for streaming voice and video data. Right now, my data is streaming. My voice and video is streaming in between my laptop and your laptop. Meaning a fast communication is what needed. UDP is what currently used, not TCP. Right now, UDP is used. I can show you that. I can show you. There is a tool called Wireshark, using which I can sniff and show you what currently my voice means. Whatever the data that goes out from my laptop, I can capture and I can show you. See, all are UDP. You see, UDP, 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 UDP. From my laptop, it is going to Google server. You see, user datagram protocol. And my voice that I'm generating, the video that I'm sharing with you, it goes to Google, you see. Google. It goes to US. From Google, it goes to you. Organization is Google, autonomous system number, country is US. This is the latitude and longitude of Google location. From there, it goes to your location. So I cannot see your location because I'm using Google's application. 144.250 is Google's address, not your address. Through Google, via Google, it goes to you, your router. Let me stop this. So this is what we have in the transport layer: TCP, UDP. Now there is also one more ID that is used in transport layer called port number. See, earlier we saw IP address as an ID, MAC address as an ID. There is also another identification of your data. In transport layer, we use port number. What is port number? A port number is a numerical value that identifies the service. For example, this is one computer, another computer. From this computer A, if I am telnetting, what? Telnet. See, you know what is tel? Means, television, telephone, telnet. Means in all this, if you see, telephone means phono, voice. From remote, when someone is talking, I can hear. That is called remote voice. Telephone, remote voice. You are not near, but I am able to hear you as if you are very near. That is telephone. Television. Something happened in Turkey, the big earthquake. You are able to see as if it is right now happening in front of you. Television means distance. Tel means distance. Vision. You see. Likewise, telnet, meaning if I want to see this computer down here, if I want to see inside this computer, if I want to get inside this computer, we call it as telnet. Even though I am sitting in this computer, I can go inside this computer and do some work in that computer. For that, we use a protocol called telnet. The same telnet, in a more secured way, we call it as SSH. And for the web pages, we use HTTP. Secured web pages like bank pages, HTTPS. For transferring the file, we use file transfer protocol, and so on. We have a lot of services, a lot of protocols in transport layer. If I am telnetting, the port number given is 23. So when a receiving computer receives the number 23 as a destination port number, it knows that you are requesting for a telnet. If you are trying to access a web page, port number 80 will be assigned. When a packet goes to B with port number 80, B will understand that you are looking for a web page. Because number 80 means, as per the standard, web page, HTTP. If it is 443, every device on earth understands that you are looking for a secured web page. If it is 2021, everyone knows that you are requesting for file transfer. If it is 22, it is SSH, means secured way of telnet is what called as SSH. SSH is also a telnet, but more secured way, encrypted way. You see, these are all few examples of type of communication that we do in the network. How do you differentiate one communication from the other? How do you know? How do you differentiate HTTP from SSH? The port number. The receiving router, the receiving computer, if it receives number 80, it understands that you are looking for HTTP. If you send port number 23, the receiving device will understand that you are looking for telnet service. So the port number in transport layer helps to identify the services. These are all examples for services. Services are identified by number between 1 to 1023. For example, 23 is in between this range for telnet. Yes. You don't need to memorize all the services. These are the few uh, widely used services. So I have written here. You need to memorize this telnet 23. No by heart. SSH means 22. HTTP means 80. HTTPS means 443. FTP means 2020, 21, 20. You know. Likewise, we have various protocols and services. We cannot remember all of them, not necessary at all. But here I am trying to explain you that port numbers are there to identify different services that we have in network. Different services, different port number. You go to KFC to have some food. There are varieties of food in KFC. Each food has got a unique name. Likewise, there are varieties of services that a computer provides. Each service has got different name because each service has got different purpose. The different name is in the form of number here. 23 is a name given to telnet service. 443 is a number given to a secured web page, and so on. So in our today's class, we have covered the complete OSI reference model, Open System Interconnect. I would like you to go through the video once, twice, thrice, till you get the complete story of what I have explained. Then come up with some doubts in our next class. Do you have any question right now? You can ask me.
I don't have any right now. I'll look over it.
Yeah, I know it is a little bit heavy. Yeah, but take your time.